In this session, we will discuss about the combinational logic circuit. The point is Kmap reduction technique for the Boolean expression, minimization of Boolean functions up to 4 variables, SOP and POS form. So let's start the session. Kernop's map, that is Kmap. In the algebraic method of simplification, we need to write lengthy equations, find the common terms, manipulate the expressions, etc. So it is the time-consuming work. Thus, Kmap is another simplification technique to reduce the Boolean equation. It overcomes all the disadvantages of algebraic simplification technique. The information contained in a truth table or available in the SOP or POS form is represented on Kmap. Kmap structure for two variables. A and B are the variables or the input. 0 and 1 are the values of A and B. And two variables Kmap consists of 4 boxes. That is 2 raised to 2 is equal to 4. So A values are here. That is 0 and 1. And B values are here. That is 0 and 1. Inside 4 boxes, we have entered the values of Y. That is output. So here A bar, B bar, A bar B, A, B bar, A, B. So in this first box, 0, A is equals to 0 and B is equals to 0. That is M0. A is equals to 1 and B is equals to 0. That is M1. A is equals to 0 and B is equals to 1. That is M2. And A is equals to 1, B is equals to 1, that is M3. Kmap and its associated minterms are here. Then relationship between truth table and Kmap. So here are the relationships of truth table and the Kmap. Kmap structure for 3 variables. A, B and C are the variables or the inputs. 3 variable Kmap consists of 8 boxes, that is 2 raised to 3 is equals to 8. 1, 2, 3, 4, 5, 6, 7, 8. We can box here like this, we can box here like this. And here the values of 8 and here the values of B and C. 3 variable Kmap and its associated product terms. So here A is equals to 0, B is equals to 0 and C is also equals to 0. That is A bar, B bar, C bar. Here A is equals to 0, B is equals to 1, C is equals to 0. That is A bar, B, C bar. So likewise these values. 3 variable Kmap and its associated minterms. If A is equals to 0, B is equals to 0 and C is equals to 0, that is M0. A is equals to 0, B is equals to 1 and C is equals to 0, that is M2. Likewise these values are there. Then Kmap structure for 4 variables. A, B, C, D are the 4 variables or the input. And the boxes are 16, that is 2 raised to 4 is equals to 16. So here is the value of A and B. And here is the value of C and D. So 4 variable Kmap and its associated product terms are the, if A is equals to 0, B is equals to 0 and C is equals to 0, D is equals to 0. That is A bar, B bar, C bar, D bar. And likewise these the values. So the minterms are the 4 variables Kmap are, if A is equals to 0, B 0, C 0, D 0, that is M0. A is equals to 0, B is equals to 1, C is equals to 0 and D is equals to 0, that is M4 and like this. For example, SOP equation is given as Y is equals to A bar, B bar, C bar plus A bar, B bar, C plus A, B bar, C bar plus A, B, C bar plus A, B, C. The given expression is in the standard SOP form. Each term represents a minterm. We have to enter one in the box corresponding to each minterm as shown below. So here B is equals to 0, C is equals to 0, that is B bar, C bar, and A is equals to 0, that is A bar. And so here in this box 1, so the values are A bar, B B bar, C bar. Here is the word, that is A bar, B, A bar, sorry, A bar, B bar, and C, and like this. Then we have discussed simplification of Kmap. Once we plot the logic function or truth table on Kmap, we have to use the grouping technique for simplifying the logic function. Grouping means the combining the terms in the adjacent set. The grouping of either ones or zeros result in the simplification of Boolean expression. If we have grouped the adjacent ones, then the result of simplification is SOP form. If we group the adjacent zeros, then the result of simplification is POS form. While grouping, we should group most number of ones. The grouping follows the binary rule, that is, we can group 1, 2, 4, 8, 16, 32 numbers of ones. We cannot group 3, 5, 7 numbers of ones. So pair is called as a pair is nothing but a group of two adjacent ones is called as a pair. Chord, a group of 4 adjacent ones is called as a chord, and octet, that is a group of 8 adjacent ones, is called as a octet. So grouping of two adjacent ones pair. A pair is in one variable. So here the 8 boxes are here. Here the values of BC and here the values of A. So here is the 1 and 1. So we can combine or grouping these two ones and form the equations A bar B C plus A bar B C bar. So we can common here we can common here A bar B. So in bracket C plus C bar, and C plus C bar is equal to 1. So y is equals to A bar into B. Here the grouping of two adjacent ones pair. Here the values of BC and here the values of A. So we can pair adjacent, that is this one and this one we can group here, and also these two ones we can group here. Also we are grouping these two ones and these two ones also. So overlapping is allowed. So here also same case. These ones and these ones grouping are possible. So grouping of two adjacent ones pair. So here is the adjacent ones and we can group this pair. The possible grouping of 4 adjacent ones, that is chord. So we can group here 4 ones and here also 4 ones. Possible grouping of 4 adjacent ones chord. We can group here this 4. We can group here this 4 also. So we can group here like this also. This one, this one, this one, and this one. That is corner pair, and this one also possible. So we can overlap here 4 ones also, and here 4 ones also. So this is also allowed. Possible grouping of 8 adjacent ones, that is octet. So we can group here 8 ones. Here also 8 ones. We can group here also this 4 and this 4 together 8, and this 4 together 8 group are possible. So groups may not include rules for Kmap simplification. First rule is group may not include any cell containing a 0. So if here 0 and here 1, the group cannot possible. That is not accepted. Only one group of ones are accepted. So here 1, we can group here. The second rule is the groups may be horizontal or vertical, but not the diagonal. So we cannot form the group like this, that is diagonal one, and is not accepted. So here we can group here once and we can group here once. So third rule are group must contain 1, 2, 4, 8 or in general 2 raised to n cells. So here 3 ones are grouped together. Here the 3 ones are grouped together. This is not the accepted. we can accept here these two ones are grouping together and these two ones are grouping together. Like this, these two ones are grouping together and these two ones are grouping together. Rule number 4 of the Kmap simplification is each group should be as large as possible. That is here we can here we group the two ones, two ones, two ones. This is not accepted. We can group here most number of ones together. So here 4 ones we can group. About 4 ones we can group. So likewise the group is each group should be as large as possible. That is collection of more ones are the possible values. So rule number 5 is each cell containing M1 must be in the least one group. So we can grouping ones also. Rule number 6 is groups may be overlaps. Here we can group here 4 ones and above 4 ones. So there 2 ones are the common of the both groups. So this is the allowed, that is groups may be overlap. 7th rule of Kmap simplification is group may wrap around the table. The leftmost cell in a row may be grouped with rightmost cell and the top cell in a column may be grouped with bottom cell. So these fours and these fours are the group together. These twos and these twos ones are the group together are the possible. So rule number 8 is there should be a few groups as possible as long as this does not contradict any of the previous rules. So here two ones, two ones, two ones are grouping to each other is not accepted. So more number of ones can be grouped together. This one is the accepted. So rule number 9 is a pair eliminate one variable, 10 a chord eliminate two variable and octet eliminate the three variable. So here is the example number 1. For the given Kmap writes simplified Boolean expressions. Kmap is given here. Here the values of A and B and here the values of C. So in the first box 0, 1, 1, 1, 0, 0, 1, 0. So here we can group these ones together, and these two ones together. That is overlapping is allowed. So first group the equation is A into C bar, second group the equation is A into B, and third group the equation is B bar into C. So simplified Boolean expression is Y is equals to B C bar plus A into B plus A into C bar. So this is another equation. These are the examples of the Kmap simplification. We can group here more number of ones. These are all the examples to minimize the Kmap. Another point is Kmap for product of sum, that is POS expressions. Kernop may can also be used for Boolean expression in the product of sum form, that is POS. The procedure for simplification of expression by grouping of cells is also similar. The letters with bar, that is not, represents 1 and the unbarred letter represents 0 of binary. A 0 is put in the cell for which there is a term in the Boolean expression. Grouping is done for adjacent cell containing the zeros. Then for example, simplify f of ABCD is equals to pi of m 0, 1, 3, 5, 6, 7, 10, 14, 15. So we can plot here Kmap and the group is formed. So final simplified expression is f of f is equals to a plus b bar into b bar plus c bar into a bar plus c bar plus b into a plus b plus c. So here is another example to solve the POS form. So last point is Kmap and don't care conditions. For SOP form, we enter ones corresponding to the combination of input variable which produce a high output, and we enter zeros in the remaining cells of the Kmap. For POS form, we enter zeros corresponding to the combinations of input variable which produce a high output, and we enter ones in the remaining cells of the Kmap. But it is not always true that the cells not containing ones in a SOP will contain zeros, because some combinations of input variables do not occur. Also, for some functions, the output corresponding to certain combinations of input variables do not matter. In such situation, we have a freedom to assume a 0 or 1 as output for each of these combinations. These conditions are also known as the don't care condition, and in the Kmap it is represented as the cross, that is x, in the corresponding cell. The don't care conditions may be assumed to be 0 or 1 as per the need of simplification. So here is the example. Simplify f of a, b, c, d is equal to summation of m 1, 3, 7, 11, 15 plus d 0 to 5. So here we can put one cell number 1, here 1, cell number 3, 1, cell number 7, 1, 5 is the don't care condition. We put here cross like this, and we can adjust. For example, here is the 1, here is the 1. Here don't care condition is there, so we can group there 4 ones. So we treat here x is a 1. So simplified Boolean expression is f is equals to c d plus a bar b bar plus a bar d. So we will discuss the next point in the next lecture.